So by now, you are becoming an expert in solving equations, one-step, two-step, and multi-step equations. And you've been able to apply those equation techniques in proportions as well. But there's more equations out there than just what you've seen. And so one of them, one type, deals with absolute value equations. Now, absolute value is defined as the distance from 0. So when we see these bars around a number or an equation, well, those bars right there mean that we're dealing with the absolute value of 4. Well, how far is 4 from 0? Well, it's just 4. If I can get to my right tool. Going to the middle here, how far is negative 4 from 0? Well, it's also 4. So when we see an equation with an absolute value around the x, we're thinking, okay, well, what can you put for x that would result in an answer of 4? Well, x in this case could be 4 or negative 4, which means we could also write this as x equals positive or negative 4, either way. So this is fine when I'm circling, or this is fine. Either one, you don't have to have both. So when we solve absolute value equations, what we want to do is we want to follow just a couple steps. Here's the first, number 1. Get the absolute value alone on one side, which means if there's anything added or subtracted, multiplied or divided to the absolute value, we have to move it to the other side. So, and after that, in most cases, you can set up two equations and then remove the absolute value signs or sign. So let's put this into action here. So we're going to solve these three that you see here. The absolute value of x is equal to 15. Well, think of two numbers that are 15 away from 0. Well, if we think about that on a number line, here's 0. So there's a number to the right of 0 that's 15 away. And there's a number to the left of 0 that's 15 away from it, namely 15 and negative 15. So x is equal to plus and minus 15. All right, let's put our steps into action. The absolute value in this middle problem right here is already isolated. So what we do is we split it into two equations. One being x minus 3 equals 8. The other equation is x minus 3 equals negative 8. And now we solve. So on both equations, we'll add 3 to both sides. I'll do that simultaneously here. And over on the left side, we're going to get an answer of x equals 11. And on the right side, we're going to get x equals negative 5, which is right. Both of them are. If we put both numbers in for x in the original equation, we're going to get 8. So the absolute value is really making something positive. Whatever's inside the absolute value will eventually become positive, okay? Distance can't be negative, okay? All right, last one in this row. The absolute value of 2x minus 7 is equal to 3. So absolute value is by itself. So the first equation would be 2x minus 7 equals 3. Second equation, 2x minus 7 equals negative 3. Okay? So we're going to add 7 to both sides. Let's just solve this first one all the way. So 2x is equal to 10. We have to divide both sides by 2. And x will equal 5 for the first one. Over here, same steps. We're going to add 7. Let me change that up here. So add 7 to both the left and the right side. So 2x is equal to 4. Divide by 2, and x is equal to 2 for that one right there. Let's check this just to make sure it's working. So if we put 5 and 2 in, so that's going to be 2 times 5 minus 7. Well, that would result in the absolute value of 10 minus 7, which is 3. The absolute value of 3 is indeed 3. That works. Let's try it for 2. So this would be 2 times 2 minus 7. It's the absolute value of all of that. So 4 minus 7 is negative 3. The absolute value of negative 3 is also 3, because the distance from that negative 3 is from 0 is indeed 3. All right, let's look at our final 2 items here. So we have 2 times the absolute value of x minus 7 minus 6 equals 4. So here, the first thing we have to do is we have to isolate this x minus 7 all the way first. So it's almost kind of like its own variable. So the way we're going to do that is we're going to add 6 first, and that'll give us 2 times the absolute value of x minus 7 equals 10. Now, if I divide both sides by 2, I'm going to move it over here. I'm going to get x minus 7, absolute value of that, is equal to 5. All right. Now, I can't distribute the 2 through the absolute value, so I have to do it in those steps right there. So splitting it up, x minus 7 equals 5 is one equation. And the other equation, x minus 7 equals negative 5. So I've removed the absolute values. I'm going to add 7 to both sides on the first one to get x is equal to 12. And do the same thing on the right side and get 2 and 12. So there is some special things that happen with absolute value equations. And one is sometimes we might get a situation where it's no solution. Now, you'll notice this equation is equal to a negative number. That's not the problem. Okay, absolute value can't be equal to a negative number, but we have a lot of stuff hanging around this equation that we need to disperse of first. So let's move the 6 over to the other side. And we're going to get 2 times the absolute value of 7x plus 2 is equal to negative 26. Still not a problem, but now it's about to become one. When we divide both sides, we're going to get the absolute value of 7x plus 2 equals negative 13. That's a problem. When the absolute value is totally isolated, as it is here, and we're equal to a negative number, then x is no solution. So we can write that there is no solution. And also, we can write that as what's known as the empty set, which means there are no possible solutions for x. So that's how you work with absolute value equations. We are using the skills that we've used to solve equations in the past, but we have to really focus on isolating a few things before we can truly solve everything. And it's the first time where we're getting not one solution, but 2 solutions in a lot of cases too.